It gives me a great pleasure to extend to you a very warm welcome on behalf of Electronics and Communication Department, who has clubbed all of us for this webinar on the topic Future of Nanotechnology by Dr. Godwinraj sir, Assistant Professor of Electronics and Communication Department. First, I would like to invite KG Sadish Kumar sir, HOD of Electronics and Communication Department, to give the welcome address.
A warm good evening to one and all assembled, those who are listening to us. Today's the keynote speaker, Dr. Godwinraj, respected deans, HODs, manager, principal of the college, the participants who registered. We have the registered participation from different parts of the states and in the country, expecting them to, some of them might have joined and few of them will be joining. A hearty welcome to one and all to this inaugural function of our resonance talks. This is a series of talks. We are planning to conduct it for every month. And this is the first of this series. The objective of this talk is to transfer the information which can reach the common people and also both the engineering community plus non-engineering community about the developments in the different fields of technology and science. So today, this evening, we will be having our discussion on future of nanotechnology, starting from the medicine and will go up to quantum computing. For us, today's speaker is our own friend, Dr. Godwinraj, who has done his master's, graduation and master's from Tamil Nadu, and his PhD from Jadavpur University, Kolkata. He is the award winner of Senior Research Fellow from DST, CSIR, and many more. And after his completion of his PhD, he worked more than 2 years in different colleges before joining Amal Jyoti. He worked in the Anand Sagar University, Karunya University, and then joined Amal Jyoti College of Engineering almost in 2016. For last couple of years, he was with Amal Jyoti and he has been awarded the Best Faculty Award recipient for a year. And he was contributing in a great way for the development of our students as well as for the department and college. He has been sanctioned a ham radio, community radio on his name to the Amal Jyoti. We start functioning soon. And he has got the FIST funding along with the other members and many more in his record. He is having more than 20 publications in reputed high impact journals, applied for patent and many more. And dear sir, I'm welcoming you to this department of EC, Amal Jyoti College of Engineering. The college was established in 2001, and luckily it's a coincidence. Tomorrow we'll be completing 20 years after getting the approval from AICT. 27/6/2001, AICT has approved Amal Jyoti to start the engineering courses in four branches, EC, EEE, IT, and CSE. Now, we are with the 10 branches. At that time, we are in 180 seats. Now we have 10 branches, or 10 specialization BTech with 840 annual intake, then 10 MTech program, 3 MCA program. The college is situated in a serene campus of 65 acres land with 17 lakh square feet campus area. More than 3,500 students are studying in this college and almost 350 plus staffs are working in this college. Dear sir, I welcome you to this function, and all dear participants, a cordial welcome to this function. And I am sure this section or this webinar will be highly fruitful for you, and you will get a lot of information. For a researcher, you will get an idea to continue their research, or a new spark in the research. For the graduate students, will get an idea how to divert after their graduation. Once again, I am welcoming Godwin sir for the program as a keynote address.
Thank you, sir. Thank you so much. So I'm thanking HOD management for your wonderful support and the guidance for this wonderful webinar. Also for supporting of financial like nice lab establishments and Nano research in this Amal Jodi. I'm very grateful to sir as well as the management and each and every faculties of Amal Jodi. So I'm sharing my PPTs. Yes. So that so nano electronics, something we are heard about nano is it is very enthusiastic domain. Along with that, it's very complex domain. So as we think that nano is a future domain, we can say, where people are working in a research level as long time as well as the fabrication levels. So the fabrication is nano is something held by some of the reputed industries like Intel, Qualcomm. So these all will allowed by many people. So these are like the nano electronics and nanotechnologies held by industries, and many of this simulation part and research is done in India along with that. So if you think this nano technology or nano electronics, so there are huge number of applications exist today. So we are using as long years we are using this nanotechnology as an application of from medicine to there are n number of applications we are going to see today. So about this nanotechnology and nano electronics, especially nano hardware, we are going to work in this particular way. So that this content I'm going to make very short. I don't want to make a very detailed study about the research, and I just going to touch some basic things about what is nano hardware and some of the key point about future nano devices, especially like some memory applications and PCB applications and ink printing, quantum computing. So these are the applications will make us to think, is it really possible a nano device is going to outbreak such a big achievement in this area? So that field is going to get out of this nano device technologies. So that some of the technologies are not really available today. So some of the technologies are exist. So some of the technology are going to discuss in the research mode, and that's going to be a challenge. And second part of this webinar, we are going to discuss something about like so how really we can implement this, use this technology to make a product outcome from this nanotechnology. So there is a no utility if you are not utilizing nanotechnology, is nothing going to come out from nano. So really, so what are the tools we are going to use this nanotechnology as a cheap cost? So then the second part of this going to work, we are going to discuss about. So if you are working from home, like the challenges we face today because of lockdown and COVID issues. So still your research in this or still your project is going to be done from home also. It is possible nano projects can be done from home, or these tools can be used from home, or any projects can be done from home. Some of the ideas we can going to discuss. So how we can utilize this technology even in today. So even you are in lockdown, how can it be utilized? And we're going to see some of this future. We're going to what technologies can be advanced and going to be done. So I'm going to start. So very basic idea, like if you are going to use a smartphone, so you can see there are three different kind of people are going to see. So like some people need that I need a mobile phone, but I need a phone which needs to have some basic features. So like I don't want a phone should have very big features, like I want to use some of the features less. So some people we can find, and some people say that I need a phone should have some advanced features. So if they ask that advanced features, they'll say it should have some good memory, and it should have some good camera, it should have some good editing options, and it should have some good battery backup, and it should be portable along with that. So yes, that I'm satisfied with the phone. And some people, if they buy the mobile phone, and they will see some of the benchmark features of the mobile. So we are going to see what these people think about this benchmark features in this mobile phone. So these, when the people buy a mobile phone, I'm starting very basic level. So they'll see some of, yes, this fingerprint is there, mirror is there, 5G is there, extended RAM is one of the very good feature we have. The RAM can be extended in mobile phone also, and very good backup is there. And yes, And one of the things is that there is a processor, and people are going to see what is the generation of the processor. So the generation of the processor is going to make a distinct involvement in this development of nanotechnologies. So a processor is something like very hard part of the mobile phone. So if you have a very good processor, even you open a mobile phone, even you use a 10 tab or 20 tabs continuously, you're operating your WhatsApp in one side or some other applications on the other side. No issues. Your phone will get work long lasting. It can able to handle the operations by holding the power consumptions. At the same time, it can able to give parallel operations without slow your mobile phone, and it can give very better performance. So the generation of processor is basically talks about the enhancement of the technology we are using. So as we know, this nano, I hope nano is aware about everybody. So the size basically we can be able to see in the range of millimeter. We cannot able to see less than a millimeter by human eyes. So if you see a person, he'll be having around in nanometer, we say a person will be there having 2 billion nanometers a size of tall, a 6 feet tall person. An apple of 8 centimeter, we can say it is 80 million nanometers, and we can say it's 5 million nanometers. So if you go to a human hair, you can see a diameter of the hair is something around 75,000 nanometer is the size of the diameter of the human hair. And less than that, you can see, we can say a coronavirus. So coronavirus is something less than around 100 nanometers, or nearly that, 100 to 200 nanometers. So what is the problem is we cannot able to see coronavirus. It is very tough for people to see a coronavirus. So we have to go for some sophisticated tools like SM and high resolution SIMs. So that is then less than that 100 nanometers. We have a DNAs, and we have a carbon nanotubes, and there is a less than that we have a buckyballs. So that is the atomic structure of a carbon. So there is a big world is there inside a nano. As you not think, is there some very huge area is there in nano? But you know, the current technology we are using transistors in processor is really about 5 nanometer is the least size we are using in a mobile phone processors. So imagine how could be a one transistor size in a processor, how small it is. They say 4th generation, 5th generation, you heard about Intel processor, 5th generation, 7th generation. What 8th generation says? So this generation says that these processors are going to work extraordinarily, very high performance, and even the size of the transistor is going to be exactly small. For example, I say I'm going to use a 45 nanometer transistors. Okay, imagine I'm going to use a 45 nanometer transistor in 2019. And if I use 22 nanometer transistor, what has happened? The size of the transistor is exactly half. So what really happened is, instead of in the area of 45 nanometer, I can keep two 25 and 22 nanometer transistors. Okay. And if I go for 14 nanometer, in the same area of 22 nanometer, I can able to place even 2 more transistors, like 14 and 4 transistors I can able to keep to make around 48 or 50 nanometer technology. So what is happening? The number of transistors is increasing. So what is the use of huge number of transistors? So in electronics, every processor, whatever you type in a mobile phone, whatever the operations you are doing in the mobile phone, is handling as a digital logic. So digital logic means binary logic as a zeros and ones. Okay. So each and every transistor will send the data as a binary logic in a transistor. What is the use? If you are having 1 billion transistors, 1 billion number of binary data can be sent. If you have 2 billion transistors in the same size, 2 billion operations, 2 billion data can be able to send. It can be a logic operations or it can be a processing. So that is the very big advantages of this particular scaling or reduce the size of the transistors. So that is a very key part of this particular transistors. So that is called, as we say, this is as a Moore's law. So Moore's law states that every 18 months means, for example, in 2019, I'm using 45 nanometer technology. After 18 months, I have to go for 22 nanometer technology. Means I have to go exactly half the size. So the scaling is continuous, but the problem we achieved is, even when you scale the transistor size, the power dissipation is reached a saturation. The power dissipation from the processor is very big challenging today. So what really happened? In order to get very good performance from the processor, people start to use the coolers. You know, hydrogen coolers. There are water coolers. So what does really happen if you use a very good cooler? The performance of the transistors can be enhanced. The heat control or the power dissipation can be managed so that the transistor can able to work effectively. Okay, so this is what a Moore's law, and this is what the generations of the transistors. We can use many number of transistors as the Moore's laws. But we reached a saturation, and after 25, there are a very big challenging, and I don't know how they are going to manage this issue, because we cannot able to scale a transistor beyond a particular limit. Okay, so what people thought that, so we'll go for a multi-core processor. Multi-core processor means instead of same one processor, we can have many processors in the same area. We can have like 4 processor, that is called 4-core processor of 1.8 gigahertz. Instead of, we can say there is a 4 into 4 core processor of 0.9 gigahertz, or we can say 2 into 4 core of 1.8 gigahertz. So we can make us a multi-core to manage this participation and to manage equally distribution, the frequency of operations, or the power handling and the frequency of operations. So this is a basic transistors, how the transistor is going to work. So using the transistor, now we made a hardware. Okay, so now the transistor is made, and we made a processor, and this processor using this transistor, we made not only the processor, we are going to make the sensors, we are going to make activators, we are going to make so many things. So that is made out of from the processors. Okay, so now this processor I'm going to use in one of the very challenging application called biomedical. So in the biomedical, as many of you know, if you're working in electronics, you would know about the sensors. We have the proximity sensors, an EEG sensor, blood pressure sensors. These sensors can be interfaced very easily with a mobile phone or laptop, and that data can be stored to the medical database and can be accessed from the emergency when there is a required. A doctor can make this advancement is nearly coming so fast about the interfacing of sensors. Okay, so now that is a very, we can say that is a, even it's not come in the market, that is absolute as a nanotechnology person. Okay, so what is a very advancement, or we can say very challenging as well as a very effective one for a nano application of in medicine is called as nano robot. Okay, as we know the robot, we know that robot is controlled by some actuators, some hardware is there, some memory is there, and some processing is there to process the information and store and to handle the operation as per the command. It's very simple. But imagine a size of a robot in nano size, a size of the robot in nano or micro scale. So it's very challenging. It is, even we saw that a robot is a very huge scale, but you see a robot in a very small size of nano and micro, that is going to be a big outbreak in society for a future medical applications. How it is going to be used? Yes. So a robot is, what is, if this robot size is very small, so it can able to swim through our bloods. So it can able to swim through our blood and it can able to reach our destination. For example, the target area. I want to reach that particular cells of like tumors, and I want to apply the dosage of medicines. I want to destruct that tumor areas, and it can be come back. Now the second challenging part of this particular robot is control of the robot. Sometimes if you lose the control of robot, what happens? It will mix your bloodstream and it can able to move many part of our body even without knowing about your knowledge. So that is very challenging about this nano robots, which people are going to work. Okay, last few years back, a 2 centimeter long nano robot is made, very big outbreak is made, much smaller robot which can able to handle operation of healing and this process of repairing of blood cells, and it can able to work for a surgery in the eyes. That's already done by the people. Okay, so they use a material called carbon, so they can able to go for many elements, something like hydrogen, sulfur, oxygen. That nanoscale gear can be used to manage these kind of nano robots. Okay, so as we say that this is what robot is say, the robot is having a micro camera. So micro camera can able to monitor where it goes, what is the destination it is going now. And payload is basically used to monitor the movement of this particular robot. And there is a capacitor to make a power supply, and it is having a swimming tail. It can able to interface with the outer environment. Okay, so now we see how can able to use this robot. For example, if there is a kidney stones. So kidney stone, what you will do, you will apply some ultrasound from externally. Yes, many of you are aware about how the kidney stones they are going to break. So ultrasound they will do from outside of or under your stomach. So this ultrasound waves will reach your stones and it will break the stones and it will come through your vials, so body urine. So what really happens if you have really good robot, it can able to reach the destination and it can able to identify the kidney stone and it can able to give this ultrasound exactly where it needs to give. Instead, if ultrasound you give, it will reach and many part of the areas of kidneys where you focused. But if you give with this nanorobot, so the nanobot can able to reach the destination where you want to apply this and it can able to break the particular bots. So and another thing is where you are going to apply in the blood vessel. So for example, RBCs, you want to repair and you want to give some drug in the RBCs and you want to repair these RBCs that in the tumor cells, if it is formed in this the blood streams, that also can able to focus and it can able to reach the area and the drug can be delivered to this particular domain. And another one is we can see there is this particular issues in this blockage in the arteries. So this arteries can able to focus very clear using a nanobots. So nanobot can able to reach the area and it can able to clear the arteries and that can able to remove any blocks or any issues there in the arteries. It cannot able to solve externally or it can able to solve by surgeries. Okay, so that is a very big advantage we can say. So another thing is to identify this decode of DNA. So some extent because people have genetically some issues. So if we say I want to analyze this DNA coded, so I can able to make is effective changes, anything which is required in the DNA, so that the person can able to recover from what issues whatever he have in the futures. So that is a one application of nanobot. That is a one application which are using in the medical, we can say. So the future of another biomedical applications using this nanoscale is of a wearable sensors. So wearable sensor is something which is going to come out in the future, which is going to make very big outbreak or very big success in this market. First thing is a smart lens can able to detect this intraocular pressures, which is there in this eye pressure, can able to monitor using a lens you have. And if you have this face mask, you can able to study the breath pattern, whatever you have, and airborne pathogens which is there, and inflammation is there. It can able to monitor using the sensors which is having your face mask. And there is a small patches we can which is folded on in this side. We can able to use to study this ECG. So ECG is nowadays is made very small, and even a small scale ECGs can able to study effectively more than what we have, and it can able to hold very small as a small patches and can able to read the data. And another thing is like micro needle patches we can able to use to study this example of glucose, lactase, these values can able to monitor. And this wristband, we know this is used to study this electrolytes and metabolites of this particular activities. And smartwatches already, which is there, is used by people, which is to study the sleep, resting, and heart rate and oxygen levels. And this tattoos can able to use to study this stress biomarkers can able to study. And this textile means the shirt itself is can able to study this skin temperatures. So every part of our body or whatever this accessories we are using our in routine lifestyle can able to make as a hardware, as an electronic hardware to monitor our health. So that is going to come up in the future nano because of this nanotechnology. So unless this nanotechnology, the scaling or the size of these sensors cannot able to make such smaller, that is about very big challenge for the people. And second thing is of nano, as we discussed earlier, so we're just going to make application of nano for storage. So as you know, there's the magnetic tape we started, and floppy disk and series DVDs and hard drive USB storage. And now the people are started to work to store in DNAs and store in proteins and bacteria. So how it's really challenging is how can it be possible to store in a DNA? Yes, it is possible. And they are working in a research to store in a DNA very large amount. We're not able to imagine how a molecule that carries genetic information. That's what a DNA, what we know that. Okay, and here it contains this cytosine and this aniline and ANT thymines. So these all can able to work as a binary data transmitters. So as I say that, so we can say every 0 can become as ARC or every 1 can become as TRG. It's very easy to manage this digital code in this AT and CG. What is AC and TG? What is really happen? We can able to send the binary data, or we can able to store the binary data. So that analogy is used to, because the decoding of DNA is now is a very big domain. We can able to easily decode this ATCG. It's a very advanced instruments we have, and we can able to that genetical modification never happens, means the data is persistently exist for a long time. Okay, so now really what happen, if there is a existing of ACTG, then there will be a existing of zeros and ones. You can decode the data. Okay, so what really an amazing thing is, you can able to, in 1 gram of DNA, you can able to store 215 petabytes of data. That is equal to 215 million gigabytes of data. Okay, so that is very miserable, which is 215 million GB is something you cannot imagine how much million gigabyte data can able to store in 1 gram of DNA. So that is going to be a big breakthrough in this nano readout technology. That is especially called a memory applications we are going to use. Okay, and along with that, if I'm using this technology of bacteria DNA storage to read this molecular data, and if also I see the read and write speed of this is very small, like less than 100, you can able to do the read and write operations per microseconds. Means less than 100 microseconds I can able to write, less than 100 microseconds I can able to read it. Which is very close to 100 in flash memory, and data retention which can able to retain this data for even 100 years, and the power usage for per watt per GB is 10 to the minus 10, which is very, very small power is sufficient to store of 1 GB of data, and the density of data you can store in 1 centimeters cube area is 10 power 90 of bits. It is going to be a very miserable outbreak in this society of this particular storage applications. And second thing is, the third one we are going to see is the application in this, especially using for PCBs. So PCB, if I say about this PCB, I could remember how I was working with in my BTech, which I started. So something when we start to work in the laboratories for a project. So earlier that we didn't aware much about this PCBs, how this printed circuit boards were there. I was working. So we started to make a board something like this. Okay, so it will highly messy, and there will be a processor, and it is connected with so many wires, and it will be handling. And on the way of moving to college for presentation, one wires will go off. Say this entire circuit will not work. So say, sir, it was working yesterday and it was not working today. So that is what excuse we are going to say. So what is the solution for that? Then people thought, yes, here is I'm using a microcontroller of 8085. So I have to go for programming this microcontroller using C programming. Then advanced form is come, which is using called Arduino. Okay. So even with Arduino, your circuit will be like this. It will be hanging somewhere. Some wires will be there. It will be messy, and even any small disconnection of wires can able to lead to a non-function of your circuit. Then there is called dartboard, and dartboard circuits will be something like this one. So that also it is not looks not good, but it works very fine. But it is very difficult to make some complex circuits. Then we can go for same circuit can be implemented using PCB. The PCB circuit will be something like this. The circuit will be very neat, and it can able to hold many number of hardwares. Even sensors, it can be able to work any gyroscope, or proximity sensor, or Wi-Fi modules. Any sensors can able to hold power handling circuits, and this microcontrollers and the USB port. Everything can be holded within a single small module, and that can able to work effectively. So what really happened? The transistor that using a nanotechnology, not only we make the processors, we make these microcontrollers, we make these ICs. Everything was made out of this nanotechnologies. So this is a PCB is one of the application of this nanotechnology where I'm using this hardware, and using that I'm going to make this particular PCBs. And PCB is having two type of hardware. One is called through-hole hardware, and another is called SMD hardware. So this is called a through-hole hardware. So where we need to have some holes, we need to buy this hardware components and dig the hardware, and I have to do the soldering and make the circuit. So that is we can generally we'll make a circuit using a through-hole hardware, something like this. And this is what a SMD hardware. This is what you are going to see in the motherboards. If you take your motherboard of your mobile phones or anything, you will most often you will find many of the components of basically as a assembly hardware. It may be a capacitor, or it may be a resistors, or it may be an ICs, or it may be a regulators. So whatever it may be which we are using, majority of the components is basically in this mobile phones they are using a SMT hardware. So that is called a surface mount technology. The hardware can able to hold on top of this particular surface. So this PCB now doesn't mean that only one layer PCB you can able to make. You can make the PCB on top and bottom side. So top side I can keep the circuit for holding the hardware, and bottom side I can make the connections. And also you can give a multi-layer PCBs. Multi-layer PCB is something like not only I can make 2 layers, I can go for 3 layers, 4 layers in order to reduce this electromagnetic interference. Okay, so that multi-layer PCB is going to work very efficient, less compared to the effect of dual layer and single layer PCBs. Okay, and also we can make this flexible PCBs, high frequency PCB and low frequency. So this is one of the example of single layer PCB, and this is what the board we get, and this is what the components after placing your board, it looks like this. And this is what a dual layer PCB. This is a dual layer means this is a top layer, and this is the back side of that particular PCB. Here we are going to place the components. So this, and this is something, one of the example of multi-layer PCB. So multi-layer is basically invisible. In the simulation part, you will be able to see there are many transfer going inside this particular, and that is the final PCB which is made using the placing the components. And these are some of the flexible PCBs that you can able to make some of that flexible components, because routing of this PCB is not very easy. So sometimes you need to hold this camera. If you open your mobile phone, you can able to see this camera module, and this will be interfaced using this flex PCBs. So through some routing hardware. So this is a high frequency PCBs, especially designed for a very high frequency in order to, and this specially designed to avoid this electromagnetic interference of in the circuits. So how this PCBs can be able to make? So generally, we have the tool of PCB design tools is called Eagle, KiCad, Fritzing, and DSPCB. And there are many EasyEDA. There are many tools that we have, open source as well as the commercial tools. There is RTM software and ORCAD. So what we'll do is first we study this circuits. Yes, what type of circuits I want to do. Yes, I studied. The circuit is working fine. I done the simulation in PSpice or some sort of open source software, whatever you have. Then I'm going to have a design of circuits using this software, and that design I'm going to convert using to a PCB layout, and that layout I'm going to give order to that industries, PCB industries, which there are many industries. I'm showing some of the industries which is having called PCB way, and there's all PCBs, and these are some of the renowned and cheap PCBs you can able to make, and you'll give this design to the industry. Industry will make the PCB, and they will send this PCB without components. So there won't be any component as per your design. You will get the PCB. It won't be much. Recently, I made one PCB for 500 rupees of four PCBs. For minimum, industry will do 4 or 5 number of PCBs. They will not make 1 or 2 PCBs, 1 PCBs or something like that. Okay. So that is a very big advantage. You get cheaper. These PCBs can be done from industry. So industry is doing this much of operation for manufacturing 1 PCB. Something which is having industry tools they'll use to make a very good PCBs from that. Now we'll see what are the third technology we are going to discuss, something called Imprint Technologies. So Imprint Technology is basically biomark ink I'm using. So that ink I'm going to use to print this DNA molecules or crosslinks or that other polymer optional links can be able to print that using this Imprint Technology. So Imprint Technology, I'm using a needle, or I'm using a very small pore syringe, which is having a 20 microns or less than that, and which I'm doing a pressure, and it can able to print this particular pattern on the substrate. And second thing is I'm having a Piezoelectric Accelerator. Piezoelectric Accelerator is something like a vibrating effects. According to give your vibration externally, it can able to print the particular pattern on the substrate. And third thing is I'm using a laser assisted. So laser is working with the principle of PWM's pulses. So as you give the pulse signals, which is using at semiconductor laser diode, so it can able to control the circuits. According to that, you can able to control this flow of ink to the substrates. That necessary pattern of tissue engineering, especially for drug screening applications, that is also a very challenging application, which is going to work today in the research as well as in the production level. So this imprinting technology is now they commercially using one of the tool called this Dymatics material printer. This printer is basically like what we have a printer today. But whatever the material you want to print, just you have a cartridge and you load this material on this cartridge first, and you make your design on this particular computer, like you have a design as a CAD or you have a paint. So that design you connect to this printer and give your substrate, any flexible substrate or whatever maybe you want to print, and that material will be printed on the substrate. Now, what is the advantage? Earlier, these things all will be fabricated in a lithography or something like nano fabrication tools. Now it is not required anymore. Even a printer can able to do the operations of particular something like this is icing sheet we have, and in this cartridge I am having some cream. This is color. This is having a natural color. It's not a artificial. So this color I am going to fill in the cartridge, and I'm giving my design of particular for a birthday function. So that I printed in this icing sheet, and I put on top of the cake. So I can take along with this this sheet also I can consume along with the cake. So that is the development of a technology, especially called as Imprint Technology. That even if a food can also can able to print, and that doesn't mean that material limitation. You can able to print any type of material, whatever you want to print. So another thing is you can print this batteries. So earlier batteries are like a solid thing which has to hold a large number of storage. We need to have a heavy battery that is having very big storage. As we know, this is 6000 mAh battery or mAh battery, which is now the battery can be flexible. As the print technology we have, the material can be printed on this flexible substrates. We can make the batteries also flexible. You can able to store 10,000 times cyclic, which having very good stability. Means 10,000 times you do the cyclic process and have very good stability is achieved using a 3D printing technology of this particular. So this printing technology of this is advanced form of this particular one, which is going to come up. But the problem is in the printing technology, the precision of nanoscale cannot able to achieve like people having a fabrication of, if you say, sir, I want to make one transistors using this imprint technology, it is not really possible because those technologies, they are using optical technology to make this pattern of particular lithographic process. So here, whatever using that, whatever the size of that pore we have in this scale or in this pattern of the needle, that is the size of your scale. That is the least size you can able to fabricate. Very simply, we can say just possible. And this is another technology we can going of. So there's going is called quantum computing. So quantum computing is basically why the quantum computing is emerged. Are people working is quantum computing technology because the transistor is reached. As I told you, the number of transistors increasing as the year by goes as per the Moore's law. Now the transistor count is also increasing. Now I told you they worked on 5 nanometer technology, and the 3 is also now possible, and there 2 nanometer also they are working. But the future of after 2025, what really happens? It's not, there is nearly not possible to work on the scaling of processes. Scaling of the transistors. So what is the solution of the particular problem? So there is a very big outcome is come that is called as quantum computation. So quantum computation is something which was started 30 years back, and that is it is working with this principle of is called a quantum bits, or you say that is qubit. Okay, so as a digital logic, as you say, it is working with the principle of zeros and ones to process all the information. But in qubits, zeros and ones is existing at the same time. So the bits will be changing as there will be in this computing of binary zeros and one. You can say qubit is basically either 0 or 1. You can say that. So classical bit is they either use either zeros or 1. It may be, for example, 0 that is 0, 0, 0 for is 2, 4, 3, or we can go for 0, 0, 1 or whatever maybe the n bit we are going to translate. But in case of quantum bit, it will be 0 and 1. Okay. So if I want to identify there is a password of 0111, it is very easy to identify because quantum bit will be either both 0 or 1, and it can break the password within a fraction of seconds compared to the less than milliseconds compared to the classical bit, because classical computers always see the each and every bits of particular classifications of, but the quantum bits will be classified and it will be easily identified using qubits. So qubits will be always on 0-1 conditions, and as per this given signals and the control can able to identify the break the particular operations and this especially this IBM and Google is working on this quantum computers that can able to perform operation. They claim that it will be 10,000 crores times, sorry, 10 crores times faster than the traditional computers what we are using if you're using a quantum computing. It's very easy to, we can easily predict it because the ones and zeros will be operated at the same time. Doesn't need to do such of each and every operations in this computations. So that is a very big advantage. And another thing is this nanotechnology is not only working in electronics, the nanotechnology is also working in this, they're called as MEMS devices, micro electromechanical system. It can working in mechanical, it's working in imaging, it can working in patient monitoring, pharmaceutical research, drug delivery, and everywhere many of the domains they will see wherever there is IC processing and this activators, wherever there will be a nanotechnology tools will be used. Okay, these are the evaluation of this as the time goes on. So I'm going a bit faster. So this as the time, these years goes on, the technology nodes are keep on increasing, and this enabling future perspectives for higher speed and higher applications also going. Now the one of the thing I'm going to discuss is it really possible for a BTech student to make a low cost nano projects in the lockdown period? And second thing is, if you're working in a lockdown period, is the lab facilities are sufficient to fulfill your project ideas? So these two are very important, unless we talk 1,000 times about nanotechnology or nano tools, whatever maybe. Okay, so one of the ideas we are going is, so initially what we are going to do is, for one of the ideas we are going to implement is PCB design. It's possible really, because PCB initially we are going to make using at as I told you, we debug the circuit and we will make using a tool called something like Eagle or something, and we'll make a PCB file. So what we'll do is this PCB file we'll send it to the industry. The industry will send you the PCB. Okay. Now what is the next part is you have to apply the solder paste, and there is a pick and place machine, and there is a reflow soldering operation is there, and there's inspection, and there is a testing. So this much part is remaining. Okay. So for solder application, there is a tool called a stencil printer. So stencil we have to make to apply the solder on the particular pattern. So this is what a stencils we have. And that stencil, if you apply on top of your circuit, and you can apply the paste. So what really happened, wherever you need to apply this solder paste, there solder will be existing. Rest of the part will be free. Solder free will be there. Okay. So next operation after this is called pick and place machine. It will do the place the components. So how we can avoid these two machinery operations by you? Yes, it is easily possible. You take a syringe and you take some solder paste available in the online, and you can apply on the pads. So these are the pads we have, and you can apply this solder paste on top of that, where the pads is there. And next, what you do is this is called as you can use a tweezer or something like that, and you can take your components, SMT component, and you can hold it something like this, wherever the pad, for example, in which area you know what hardware is there, what number, what resistor is there, what capacitor is there, that you can able to hold it on the respective areas and make the particular circuit. Okay, then you can use the soil on top of, you heat the soil on top of that, you place your board, and this solder paste will hold this component and it will get solid. So your PCB will be ready, the complete PCB will be ready from your home itself. Doesn't need that the design is done from your home only. The PCB is tested from your home only. You ordered online, PCB came to your home, and you using your strings, you place your solder paste, and you place your components. Using your soil, you apply this heat, and you can hold the components. Yes, the PCB is ready. So what is the advantages of these tools? Yes, of course, if you're working with the n number of PCBs, for example, I need to make 1,000 PCBs, 2,000 PCBs. In such cases, you need a stencil, because stencil can able to reduce your time, and you can able to place very accurately, and you can place more number of components. And second thing is pick and place is something like you can do the operation much faster compared to the if you use a tweezer, it will take long time, and accuracy may be move around here. So, but in pick and place, will place very faster, as well as you can place very accurately using these tools. So, what are the challenges in this low cost PCB is something like, if unknowingly you make some soldering, there will be a bulging of this particular or excessive soldering will be heat up, this bridging will be formed. And another thing is there will be bridging between two IC legs. So these are also possible in this particular circuit. And also there will be, if you're not placing this particular solderings properly, what happened? There will be a there is a non-placed solder here because that solder base is not applied here properly. So these are some of the issues that will come through the practice. So you practice 3-4 times of placing a component, soldering and applying the heat. So we are rarely using here that the soldering leads are sorry, we have this irons are, we're not using any soldering irons here, no more. Just place the components, apply some solder paste which you buy from online using a syringe, and place the component into the boards. That is the final PCB you are making. And also, what is the advantages of this printing technology? This is one of this called glucose strip. So this glucose strip can be printed using by yourself. Doesn't need that you need to go now. Earlier, this is what we done by an industries, and is a large scale you can buy from glucose strip from online. So these are the layers which has. So using this Imprint technology, whatever patterns we have, you can able to make this particular circuit and you make the design and you put this biomarkers in this cartridge, load the cartridge, put the particular design on, place the substrate, print the zincs, especially here using our graphene. So graphene is basically a very good conductive ink we make from the graphene and it can do these operations. What is the advantage? Many layers of regions of like this we place and we place on top of it. That can be going to use as a application. It can be flexible also. Something like this one. Initially we'll prepare some material and put in this of the cartridge drop. The cartridge will place in particular drop wherever it's required in the micro scale. And as after some time it will be distributed and it will be printed on top of this. This means that this is happening internally in the cartridge and paper. So this is what substrate I want to print, or it may be a flexible like sheet, but like something sheet like this we have substrates. After printing, you will get a substructure like this. So this is a conductive ink. Biomarkers if I apply, this is a glucose strip. So that is also another advantage can able to done from your home itself, because you need a Epson printer. Very cheap printer is sufficient to do the operations, but the traditional ink can be replaced by your samples and that is printed. That's what the thing we need to do. So any number of like doesn't mean that glucose sensor can be for cholesterol biosensors, latex sensors, any number of sensors, but you need to be very clear about this linear range of and sensitivity of particular enzymes. So those knowledge you should have about blood, urine, and saliva, and tear, sweat. So in any samples also can able to measure using this advanced technology. So that also possible if you go through. So what is about this Indian electronics market? So Indian electronics market, you can say this 65% of electronics is basically imported from outside, and 20 and 25 to 30% of things are assembled in India. Okay, so we are buying all the components, especially for assembling to India, or we make it, or we buy as a whole product in India. Electronics, something you can say mobile phone or laptops, whatever it be. And also we have 100% of semiconductors we are importing. So these nano product of IC semiconductors, we are importing 100% because it doesn't have any fabrication laboratories in India. Okay, so what is the other alternatives? So we can do the simulation of this particular transistors in lockdown period also, because there are many tools we have as open source tools we have. You can do the simulation of this particular transistors and you can study the characterization of the transistor. You can publish the papers. That is also possible. Doesn't need you to go to an industry to fabricate a particular transistors we have. And this is the market size which is having in India. And there are many policies are given by the government, national policy on electronics, market access and fab policies. So these are for establishment of these laboratories in India and make product in India. There are many announcements that came to India to make your electronics to fulfill the manufacturing setup in India itself. So that is going to be an outbreak to India in future, especially for automatic vehicles. Because India is going to come up very fine. That is a very breakthrough area. So for automatic vehicles, for everything you need to have some good microcontroller and processing, especially power circuit PCBs you need to make. So that is going to be a good area you can able to work in electronics. So electronics is, as I told you, doesn't mean that you are working in only electronics. You're going to work in different field, sensors, chemical field, or automation is maybe for automobile field, or activators, maybe mechanical field. Everything can be addressed using an electronics students. That is a very big tool. So we have the PCB fab tools. These are some of the tools we had in our laboratories, and these some of the flexible tools we have. Some of the optical tools we have in this laboratory. So these are one of the PCB engraver is done by our past student at KV, and he placed in India. And and this is what the engraving units, which is made as CNC engraver. He can make the PCB using this laser also with a precision of 0.1 mm. So this is one of the pesticide detector unit. We use the tool, using the tool we are trying to make, and we made this Raman. This is called Raman Spectrometers. So using the setup, we made this detection part primarily, and also we are working on this the scaling of this particular hardware, because pesticide detector is we need to go to the field and test in the leaves whether there's a pesticide, or if apple or there is orange we have. That pesticide is very challenging one. It should be portable and it should be handy to carry, and in the fishes or where it should be portable. That is a very essential part of this particular spectrometer. So we are working on this portable of this particular tool, so that we can able to make us a product in this future segments. So thank you. So these are some of the PPTs I delivered. So any questions there you can ask. So thank you, ma'am. Very good question. How nanotechnology is used to make vaccination? So vaccination is especially very challenging one today. Everyone is not getting vaccination in right time. So vaccination, we have the drug and this base materials we have, and this combined. And this what is the use of this nanotechnology is make this vaccination composition is in right quantity or in this right. Effectively, we can able to monitor this vaccination quantity compositions using this nano devices, and is also make to vaccination delivery, or there is called a vaccination processing units. So that can able to deliver a more number of quantity in least number of time. So that is a very big advantage, especially in the period of lockdown, is application of nano devices, especially in the power sector of power applications delivery. They use this nanotechnology in the nano industries. Yeah, qubits is basically, as I told you, in this quantum computing. So if you are working in electronics, you'd aware about this digital logic. So digital logic is basically binaries of zeros and ones, and any classification of numbers we represent using zeros and ones only. But if you see in a quantum computer will be there in the form of 0 and 1. It will be 0 and 1 only. But if the target, if I want to study the crack sum, especially as I say, for example, if there is a password protected RAR file or a zip file, okay. So that breaking of this password using a traditional classical computer, it takes very long time. As you know, each and every possible way it will search. So that brute force attack, it will say, they will say, is this is possible, and it will ask you the suggestions. It is a possible way to search, but because it will set the logic using these binaries of zeros and combinations. But in what is the advantages of this qubit? You say it will be there in zeros and one at a time only. So what is really happen? It will find the target based on the zeros and ones, especially is there existing, and it will find the suit and it will be searching. So qubit can be controlled using the algorithms what we give. So I say the probability that will be like there's something like this one. According to this, qubit will change the values of zeros and ones. Doesn't need to have the many million number of transistors to control these logics. I need to have only one qubit is I can able to make 0, and 2 qubit I can say zeros and 1, and something like that. 2 power n number of qubits can able to make, and I can able to make that much of operations, and can able to logics can be made using this qubit operation. That is a very big advantages of quantum computing, which is a very boom domain is going to come, which is already there in the research mode. And Intel Google and IBM already made this computers of 72 qubits and this and that maximum. So that we can say that many simulations can able to make very faster, and it's very reliable. That is the advantage. So as I said, this human printed PCBs compared with the traditional one. Yes, we are not making a PCBs printing ourselves, because we printing PCBs from outside only, and we make. And if I say that if I laser make, as I told you, that one of the student we made one project of PCB printing. We cannot say that PCB is going to be much reliable if we make by ourselves, because PCBs are, as I told you, is billions of investment industry, they will make billions of tools they use to make a particular circuit. So we can say that the effective PCB can be made by industry only, but using the tool, what we have the laser, we can make a prototype. For example, I need to make one prototype. I want to see the results now only. I am not using this for application. Then you can use such tools. You can use your prototype much faster. That is one of the application of this this one, the prototype tools. That's handmade. And second part, as I said, the handmade placed hardware will be very similar like a placement of hardware we are using. But if you have a good practice, you can make efficient hardware. That is very important. So PCB fabrication facility, what we have in our Amal Jyoti, as I said, we have the prototype machine we have, and second part is pick and place machine we have, and third one is the pick and place used to place the components, and that is a vias creating, that is laser vias creator, that is we can make the holes for multi-dual layer PCBs, which we bought in 2021 only, these tools, which is going to be used for students. And also we have this stencil printer tool we have. Also we have this reflow oven. Reflow oven is a tool which is used to heat up PCB to adhere this solder paste as well as the hardware, others resistors and capacitors. So this much tools we have. So as I told you earlier, without the tool itself, you can able to make, but if you're working for a large scale, for something like 1,000 PCBs per day, like I need to for some application production level, these tools are very useful, not only for laboratory purposes. So carbon nanotubes is basically yes. Yeah. Carbon nanotubes was basically one of the transistors. Carbon is a very good property material. Initially, their transistor they are using material called silicon. Okay, why the silicon they are using? Silicon is abundantly available on the earth, so that the transistor made using silicon, the processor made using silicon is much cheaper. That's why our mobile phones are much cheaper compared to the earlier. So if I am using a carbon materials, the carbon is also available, but the technology is not much mature compared to the other technology. What is the advantages of carbon over silicon is carbon is having very good mobility. So mobility says that the speed of that electron movement in the carbon is much faster. So we can say the speed of one transistor in the make using a carbon will be 100 times faster than the speed using a silicon. So we can say that the processor made using a carbon can be much 100 times faster than the processor made using a silicon. So that we can say that that is what carbon nano. So why they say it's called nanotube? Basically, it's a tube structure it has as a nanocrystalline. That's why it is called as carbon nanotubes. It is not like a substrate we have. In the lattice, it is like a carbon nanotube structure. That's why it's called carbon nanotubes. It is carbon nanotubes they're using for filtering applications of. There are many applications they have, like filtering of this bacteria and virus, something like that. We can use for nanotubes also for space applications where we need to have some very high speed communications where we need, wherever the high frequency application is needed, we can use this carbon nanotubes. But it is not highly mature, this technology. It is in the research and the production only.
Thank you, sir, for answering the questions.
Thank you.
Now I would like to invite Anisha Biju for the vote of thanks.
Good evening, everyone. I, Anisha Biju, on behalf of EC Department, is here to thank each one of you for sharing your valuable time with us. First of all, I would like to extend my sincere gratitude to Dr. Godwinraj, Assistant Professor of the EC Department at Amal Jyoti College of Engineering, for the wonderful session on the topic, the future of Nano Electronics. A very hearty vote of thanks to Dr. Godwinraj for gracing your important works and sharing your findings and insights. I would also like to thank Sadish Kumar Sir, HOD of EC Department, for his welcome speech. A hearty vote of thanks to our principal and management for providing the platform to organize the webinar. I also thank all the faculty members and coordinators, Darshana Miss and Anusa, for their hard work in making this event a great success. I also thank Ria for comparing the section. A big thanks to all participants for attending the session. In short, I once again thank each and everyone for attending the session. Thank you.
Thank you, Anisha. The feedback form in order to get the certificate is provided in the chat box. All the participants are requested to fill the form. We have come to the end of our webinar. I would like to thank Godwinraj sir, KG Sadish Kumar sir, all the teachers and the participants who made this meeting possible. Thank you all once again for your participation in today's webinar. We hope to see you again next time. Thank you all.
Thank you. Thank you all.